Alright, welcome to part 2 of 2.3. I know I kind of ended suddenly. It stopped on me for some reason. But that's okay. We can continue. So, the distance equals the square root of 189. It says round to one decimal. So when I plug that into a calculator, I end up with 13.7. So that's the distance between those 2 points. Alright, let's try that again with number 7. So I have the distance equals the square root of x2, which is 13, minus x1, which is negative 3. Add that to, I just realized I used the x value and y value. Let's redo that one. Okay. So we want x2, so this is our first set of points, this is our second set of points, so that means it's x1, y1, x2, y2. So my x2 is 13, and then subtract, it's still not 13, why do I keep wanting to write 13? It is 4. So my x2 is 4, subtract negative 3, I'm going to square that, add that to 13 minus 2, and we'll square that one as well. So now I have 7 squared plus 11 squared, and this whole thing is still being square rooted. So now I have 49 plus 121. You want to add those together. I have the square root of 170. Plug that into a calculator, and I end up with the distance equaling 13.0. Alright, so there is the distance formula. Okay, example 8. Prove that CD is shorter than AB. Use either the Pythagorean theorem or the distance formula. So I want you to take a second and figure out which one you want to do. Try this one. Pause the video, and then you can see the solution after. Alright, so hopefully you have a chance to try this problem out. I decided to use the distance formula. So in purple I have line AB, and then in green I have line CD. So by doing this, I have now proved that CD is for sure shorter, because we have AB as 7.07 and CD is 6.4. Alright, and then number 9, an equilateral triangle is a triangle where all sides are equal. An isosceles triangle is a triangle where 2 sides are equal, and scalene is where no sides are equal. So we want to decide if this triangle is equilateral, isosceles, or scalene. So once again, I'm going to give you a second to try this one. Either try using the Pythagorean theorem or the distance formula. Whichever you're more comfortable with, you're going to have to find all 3 sides to figure out what kind of triangle this is. Alright, so for this one I decided to go with the Pythagorean theorem. So I just made 3 right triangles for this triangle. And so as you can see, I took the 8 and the 4. I ended up with square root of 80, 7 and 4, the square root of 65, and then 8 and 1, the square root of 65. So 2 of these sides are exactly the same, so therefore it is an isosceles triangle, because 2 of the sides are equal and 1 of the sides is different. Alright, well that is the end of 2.3. If you have any further questions, please feel free to ask your teacher. Have a great day.